This video will be about making a USB attachment to a device that you want to power with a 5-volt source. If you need more or less voltage, you can attach a step up, step down voltage regulator. But in this case, this fan works well at 5 volts, so we can just attach it directly. And that's what this video will be about. So the first thing I'm going to do is cut off one side. I'm going to leave a little bit of room here just in case. Let me get my cutting mat. I'm going to leave a little bit of room. Let me adjust this camera as well too, just so that I have the full work surface in view. Alright. I'm going to leave a little bit of cord here just in case I want to use this part in a project. Now normally a USB cord will have 4 wires inside. 2 of them carry data, generally white and green. This one just has the wires for carrying power. I know that because I already cut it open. It came with the battery pack that I'm using for my PAPR powered air purifying respirator. So the first thing I'm going to do is try to cut the outside of the wire. So I can get to so I can work with the 2 inside wires. So you see this red and black. Now if you have a multimeter, that's a device that measures voltage, resistance, and current, you can check to you can plug this into USB port and make sure that the red wire is positive and the black is ground. I've already worked with this, so I know that the red is positive, so I don't need to do that extra step. I do want to get a little bit more of this insulation off. I want to try to be very careful to cut the insulation and not the wires. It's customary when working with wiring to not show, when you're done with it, to not leave any view of where you soldered and such. But my personal idea of aesthetics, I actually like being able to see that. So I'm going to have a way of joining this wire where you can actually see the solder joint when you're done. And this is kind of nice so that if your device isn't working, then you can double check it without having to remove everything like a bunch of electrical tape or whatever is coating the wires. When I'm done with this, I'll be able to just visually see that the welds are together. At least that's the idea. And there are lots of ways of joining wires together. So one thing you can do is you could tie them both together. You could even tie a rope with them to keep them together. But that takes up a lot more space, and it kind of creates a bulky sort of knot. So if I tied these both together, then I'd have this big mess here, and also don't have all that much cord length to work with. So instead, what I'm going to do is I'm going to have a little bit of overlap, tape together at the overlap, and then wrap the wires around that initial tape and then tape again. My words are failing me, though I think visually it will make sense as this goes together. This one I'm not actually planning to save, so I cut it a bit short. Now I need to expose the wires inside, so what I'm going to try to do here is to cut I'm trying to cut just the outside of the wire without cutting the inside. And now I'm going to twist it around. And it worked out, and I have a nice braid of exposed wire that I can use for soldering. I'll try to do the same thing again. So what I'm trying to do is trying to put a cut from the outside of this wire going all the way around, but not deep enough to actually cut the wires inside. And I'm not sure if I went through I'm not sure if I cut deeply enough for this to work. I'm going to try putting a little bit on this other side here, and now see if I can twist it off. If I put too much stress, I'll end up tearing the wires, the metal wires on the inside, and then I won't be able to, I have to kind of repeat the process until I get some wires I can work with. But it looks like that was successful. And now, if you want to have any sort of sleeve around wires when you're done soldering them, it's a good idea to put that on before you're actually done joining the wires together, because once they're joined, I wouldn't be able to get this piece of straw over this USB. So the idea is when I'm done, this clear piece of straw will let me see where I soldered these wires together. I haven't personally seen someone else use this method that I'm going to show you. It goes against the common aesthetic in our society with electronics of not showing the electronics, but I like, it suits my aesthetics, which is why it occurred to me. And there's probably someone else that shares my aesthetics, and they independently very likely have also come up with the same design. It's kind of obvious. It's essentially very similar to how a square knot works. Again, I'm trying to cut just through the outer layer of the insulation around the wire. I'm trying not to cut, I want to actually cut the metal on the inside of the insulation. It was my intention to get a little bit more metal exposed there, but I'm not going to really try to fiddle that much more with it, because then I'd run the risk of damaging the metal strands on the inside of the wire, which I definitely don't want to do. So my idea here is I'm going to tape these two wires together with duct tape, and then I'm going to curl this around the duct tape so that there's kind of an extra layer of strength. And I'll show that with the actual duct tape. So right now I'm not using duct tape for insulation, though, since this is just a 5-volt low amperage source. Insulation isn't as important. So the idea here is I'm going to tape I'm going to solder one set of cords on one side of this joint and the other set on the other side, and then I'm going to put another layer around that, and these two cords will also add to a little bit to the strength of this wire. Of course, if these were actually pulled apart and this wire broke there or there, that would create a break that wouldn't be easy to visually inspect, and actually is a design element that counters the aesthetics that I'm going for with actually showing the joint. I guess the thing to do is not actually rely on that mechanical strength. And just leave actually a little bit of a bend at both sides. And then if this bend goes away, I will know that there was enough force pulling these wires so that they slipped through this joint. So now what I'm going to do is I'm going to tin these wires, which means I'm just going to put a little bit of solder at their ends. And I have a window open, as you can probably hear from buses and such stopping outside, but I'm going to put on a chemical filter as well. The solder that I'm working with is lead free, but there's on the inside, can't see at that end because it's sealed off from where it melted. But in the inside of this wire, there's a material that helps clean the wires as it solders. And I have this mask filters out organic compounds and other things. So I'm gonna wear this. And now I will tin the wires. So first I'm going to apply, I'm going to put a little bit of solder, and first I'm going to get, I don't want to mess up my cutting tray. I'm going to move this out of the way before I solder. So if solder goes anywhere, it will just be on this taper. And I also will so the first thing I'm going to do is to protect the tip of the soldering iron, you should it's good to kind of have a coating of that material that fluffs on the inside that protects metals on the tip. So I coated the tip. Now I'm going to do a little bit of a bead. I'm just going to coat the wires. And before I coat the wires, I want to make sure they're straight, don't have anything hanging off of them. Almost out of solder here. If you don't have a soldering iron, you can join wires by just twisting them together, but you get a much better connection if you use the solder. And I'm just trying to line up the wires so I can solder them together. There are devices that will hold wires for you. I'm going to use some tape instead. Masking tape is good for something like this where you don't want to keep things together for that long. I just want this to hold together just long enough so that I can solder it. So I'm going to position this wire where I want it. And then I'll position the other wire. Don't want the tape to actually block the weld. All right. That's what I'm looking for, is that two wires. Oh, no, they're not quite. Okay, I have the two wires held together, and I'm going to solder them. Putting the little melted ball of solder right there allows for the heat to transfer a lot more quickly to what you're trying to solder together. I had it and then I actually kind of messed it up. So right now, that's not quite how you do it. Alright, I think I have this together now. Having the same issue where I'm kind of pushing them apart. This is where it probably would help to have one of those devices that holds onto the wires for you. That's not a perfect weld, but I'm going to leave it as is. Because if I knock it around, it's likely to come apart. Now I'm going to do the same thing on the other side. With the positive wires, which in this case are red. Red is not always positive, but in this case it is. I'm going to try a different technique for scaffolding these wires, I'm going to try to use kind of continuous. So right now I'm thinking about how to make this scaffold. I think I'm actually just going to make it out of a single strip of tape. I want to have a place for where the actual soldering is going to go on. So I'm just going to tear out a little part. And so I'll attach one wire here, another there, and see if this hopefully works better. So that grabs that wire, and then looks like I have too much of a gap, so just fix with a little more tape. I think this will work a lot better than what I was doing before. Okay, and I just need this to hold together just long enough for the solder to go on. And I'm much happier with that joint. So that method worked. Because these wires are very thin, there's not that much solder on there. That heat dissipates pretty quick. Sure if this tape will be able. Fortunately, that straw isn't going to fit over, so I would need a wider straw for what I'm doing. But I can kind of still show you what my main design is. That now that I have these joints made, apply another strip of tape. Around to hold these in place. And right now these solder points are held apart, so I don't have to worry about them coming in direct contact. And I can still see that they're joined. So to me, I kind of like the aesthetics of being able to see the material. Unfortunately, I wanted to have a layer of insulation, and my initial plan for that won't work because I need a wider straw. I think instead what I'll do is I'll put some clear tape around this just there's a mild source of insulation. Being very careful not to cut these wires. Like that. That. Just put on instead I use this to provide definitely don't like the aesthetics as well as I would have with the straw, but you can still see those joints in there. One thing that was nice about the straw is you could just cut away the straw and get quick access to the wires on the inside. So this video was to show you how to connect a USB cord to a device to be powered off of 5 watts. In general, the red cord in the USB is positive and the black is negative. A lot of computer fans have the same coding where red is positive and black is negative.